Solution for a solution lab. What you're going to do in this lab is take a saturated saltwater solution and analyze its composition. You're going to be essentially looking to find the grams of salt present, the volume of the solution, and the mass of solvent or water that's present. And you're going to do that by boiling it. The recommended procedure is that I would say you should put some aluminum foil underneath the Erlenmeyer flask in order to capture any overflow and that we collect all of the salt that's in the solution and you don't lose too much. And then I'm going to ask you to cover the top with a piece of aluminum foil that you have poked some holes in so that the water vapor can escape but you don't get too much splatter. Using the composition, we're going to describe that concentration and other things in these terms. So we're going to find the molarity, which is moles of solute per liter of solution. Using those pieces of information, you should be able to find that. Solubility, which is grams of solute per 100 grams of water. Using that information, you should be able to establish that ratio. The molality is the moles of solute per kilogram of water. So using those pieces of information, again, you should be able to find that. Mass percent is the mass of the solute per mass of solution times 100. Mole fraction is moles of each component divided by the total number of moles. So two separate equations. One is the mole fraction of salt, one is the mole fraction of H2O. Parts per million is micrograms of solute per grams of solution. And then the theoretical boiling point and freezing point can be calculated out using our equation that we learned the other day. We were going over colligative properties as the change in boiling point is equal to a constant times the molality times the Van Hoff factor, or the number of particles the solute breaks into. And the freezing point is the change in freezing point is equal to the constant of freezing times the molality times the number of particles it breaks into. And then you can compare that to the actual boiling point that you're going to measure in the lab and calculate the percent deviation, figuring out how much you're off by divided by what you predicted it should be. And that's basically the lab. There are several sources of error you might run into, and in your lab report I want you to account for those as well as demonstrate all the calculations. In the introduction, I want you to describe each of these things that you're going to be calculating and basically give a problem-solving strategy for how you're going to reach each of those values.